Concavity. Two things to concavity. It's either concave up or concave down. For this first part of the graph, it's concave down because it's bending downward. That's basically what concavity is. And you can tell that's concave down because the line of tangency is above the graph. If the line of tangency is above the graph, then it's concave down. As opposed to if it's concave up, the line that is tangent to the curve, it will always be below the graph. And so that's how you can tell if it's concave up or concave down.
The inflection point,
AKA inference point.
is where the graph changes concavity, like right here, goes from concave down to concave up. It's you set the second derivative equal to 0 and solve for x. Concave up is where the second derivative is greater than 0 and the slope is increasing, like right here, it's going from negative to positive. Concave down is where the second derivative is decreasing, or is less than 0, and where the slope is decreasing. So this is a positive slope and then gradually changes to a negative. Our first example is f of x equals 2x to the fourth minus 4x squared plus 1. The graph looks like this, and we're going to have inflection points right there because the concavity changes. But to find those points, we have to set the second derivative equal to 0. So we went ahead and found the first derivative and then the second derivative. Set it equal to 0, and our inflection points were at positive and negative 1 over square root of 3. To find the y value of these points, we plugged in the inflection points back into our original equation, and we found that the y value is negative 1/9 for the positive 1 over square root of 3, but for the negative 1 over square root of 3, it would also be the same value, because if you just plug 1 over square root of 3 back into a squared or a fourth, it's still going to be positive. And then when we had to test if those were actually inflection points to see if the sign changed from positive to negative or negative to positive. And we did that because if the sign did not change, it would not be considered an inflection point. And we also, to see if it's concave up or down, we plug in a value on the left side of one of the inflection points to see if it's positive, and we plugged in negative 1 to the second derivative, and that is positive, so it's concave up from negative infinity to negative 1 over square root of 3. And then we plugged in 0 to see if it's concave up or down between these two inflection points here, and it's concave down because we get a negative number in the second derivative. And then we also plug in 1, and we found out that is concave up. You could also look at the graph. In this example, the equation is concave up from negative infinity to negative 1 over square root of 3, and 1 over square root of 3 to infinity. It's concave down from negative 1 over square root of 3 to 1 over square root of 3. And the inflection points are positive or minus 1 over square root of 3 and 1/9, negative 1/9.
Yep. Alright, for our second problem, the graph that we chose was cosine of x from 0 to 2 pi. And so what you do is you find the first derivative, and then you find the second derivative, so it's just negative cosine of x. And you set that equal to 0, so that it's equal to 0 at pi over 2 and 3 pi over 2. Okay, so then what you want to do is you want to choose, since there's two inflection points, you want to take three numbers, one less than both of them, one in between them, and one greater than both of the inflection points. And you plug those back into the second derivative. And this is to show what its concavity is, if it's concave up or concave down. And so when you plug 0 back in, cosine of 0 is 1, but since there's the negative, it'll be concave down. And when you plug pi in, cosine of pi is negative 1, but with the negative, it'll turn it positive. So that's 1, so it's concave up because it's greater than 0. And then when you plug 2 pi back in, you get the same thing as 0, so it'll be negative 1, so it's concave down. And then, okay, so then what you want to do is find the y value of the inflection points. And so you plug the x value back into the original equation, and you get 0 for each y value. And so the inflection points are pi over 2, 0, and 3 pi over 2, 0. And you can see that it's concave up from pi over 2 to 3 pi over 2, from here to here. And that it's concave down from 0 to pi over 2, from here to here, and 3 pi over 2 to 2 pi. So the last part of the graph.